Hi, second rant, this time about the much misunderstood and much maligned watchdog timer. First, some important items. I'd like you to subscribe to the channel. I need all the help I can get. Click on the like button because obviously you're going to like this video. Then click on the bell notification icon to get notified of all updates. And finally, support me on Patreon if you can, please. There's a link in the description below. All donations gratefully received. You see a lot of this type of message in support groups, Facebook groups, various groups wherein lurk beginners, newcomers to ESP8266. They may well not have seen a soft WDT reset on the type of MCUs that they're used to working on. And they don't know what it is and they don't know how to deal with it. This video is for them. So I didn't just wait around coincidentally for that to happen so I could take a screenshot for this video. I made it happen by writing a simple piece of code that's guaranteed to cause it. And there's the code. And the line that causes it is that while statement. Now, we're not going to go into too much detail at the moment about why that particular line causes it, but here's the thing. I can do it at will. So I know what causes it and I know how they happen and why they happen. And I'm going to talk to you now about those things. So let's look at what a watchdog timer is, how it works, and why you get that message and how to go about solving it. Many of you will have seen a Windows blue screen of death. Some of you may have seen the equivalent on a Linux box. It's called a kernel panic. And the fact that they're different machines, they're different OSs, the message is the same. Both machines are telling you that something seriously fatal has gone wrong and they cannot continue to run. Okay? That's what that message says. There's three important differences between that and typical MCUs like the ESP8266 and the ESP32. And those three important differences are a keyboard, a screen, and usually somebody sitting in front of them. Because when one of those two things happens, like the BSOD or the kernel panic, you can reach across, give the machine the three-fingered salute or the big red switch, and you can restart it and make it carry on working. Typical MCUs do not have those three things. Typical MCUs live in your brakes of the car, in the engine management unit of the car, in the heart monitor that's keeping you alive at the hospital, or inside the control surfaces of the plane that's flying you off on holiday. And you cannot just reach into those places and reboot the device if it seizes up. And for that reason, because of the lack of user interface, because they are normally placed well away from any human intervention, are impossible to get at, embedded controllers have a built-in mechanism for sorting themselves out if and when a problem occurs. That problem effectively does what your IT support group tells you to do, is to turn it off and on again. Now, in all of these applications, that has to happen as fast as possible so that the plane doesn't crash, your heart monitor doesn't stop, and you don't smash into a wall in your car. And the thing that does that is called a watchdog timer. So the watchdog timer has one role and one role only, and that is to protect your MCU from bad code. Bad code will stop the MCU from running correctly. The watchdog is an independent piece of hardware within the processor that monitors for that locked up condition, and when it spots it, it reboots the machine. That's what a watchdog does. It just sits there trying to reboot the machine all the time, very rapidly. And the only thing that stops it is the machine working properly and saying, oh, hang on, don't reboot me, I'm still alive, hundreds of times a second. So there we are, there's the computer connected to the watchdog timer by a reset line. And the watchdog timer just tries to reboot the computer. That's all it does. That's what a watchdog timer is. It's an automatic reboot system. And unless you stop it, it will reboot the computer. How do you stop it? By running normal code. By running code that is alive enough to say, it's about time I told the watchdog timer not to reboot me. Because like a dead man's handle on a train, if you stop saying that, the watchdog timer doesn't get stopped, it carries on and reboots the machine. So the watchdog timer is the only thing that sits between your computer locking up and bad things happening and it working properly. So then, it's like a smoke alarm. You wouldn't turn off the smoke alarm in your house, would you? Because that warns you that something bad has already happened. Turning off the smoke alarm doesn't suddenly wind back time and stop your house being on fire. It says to you, get out now if you want to stay alive, right? Now the bad thing in this case is your code. Okay, I'm going to pause for a minute and I'm going to let that sink in because it's fundamental to the operation of the watchdog timer, your understanding of it and your correct dealing with it. Only thing that causes a watchdog timer reset is your code being wrong. And because of that, there's only one solution to it. Fix your code. Just in case you still haven't got it, watchdog timer means your code is wrong. Only solution is to fix your code. Because if you do feed the watchdog, you don't fix the source of the problem. You just hide it. In many scenarios, all you do is delay the inevitable. For example, on the 8266, there's two watchdog timers. There's a software watchdog timer that you can adjust and feed. Okay? There's a hardware watchdog timer. So if you turn off the software watchdog timer or mess around with it in a way that doesn't actually solve the problem, which it can't do because the problem is your code, then the hardware timer will kick in. I think it's about 8 seconds or something like that. So you can delay the problem for 8 seconds by fiddling around with the watchdog timer in software, but you cannot stop the hardware timer firing, and it will fire and reboot the device. And the only reason it will do that is because your code is wrong. And also, if you feed the watchdog, you sometimes cause worse problems that can be harder to find because it just drives it deeper into the machine where all the magic happens and you don't understand it. At least while it's in your code, you have the chance to find it. So let's look at the summary and the golden rules. If you think you need to feed the watchdog, you are wrong. If you think you need to turn it off, see rule 1. If you think you need to do anything to it at all, see rule 1. If you think there's any other solution to the problem than to find the problem in your code and fix your code, then you are wrong. Also, if you're an expert and you know why there's a 1% chance that some of what I'm saying isn't actually correct and that there are certain circumstances, keep them to yourself. I know what they are. If you know what they are, bully for you. But unless you are that kind of person, if you think you need to use the watchdog timer, you're wrong. Don't mess with it. Thank you for listening to this public service announcement. 30 seconds of silence at last while the end credits roll.